Hello, my name is Panika. Today we will see about the introduction of solar system. The term solar system refers to the family of the sun. Our solar system consists of our star, the sun, the planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. It also has dwarf planets such as Pluto, dozens of moons, billions of asteroids, comets, and meteorites. Beyond our own solar system, there are thousands of planetary systems orbiting other stars in the Milky Way. Deep into solar system. Now let's see about the planets and how they look like. Mercury. Mercury is the smallest planet in our solar system and nearest to the Sun. Mercury is only slightly larger than Earth's moon. Venus is the second planet from the Sun. It is Earth's closest planet and is called Earth's twin. It is the hottest planet in our solar system. Earth, our home planet, is the third planet from the Sun, the only place we know so far inhabited by living things. Earth is unique in that most of our planet is covered in liquid water. Mars is the fourth planet from the Sun, a dusty, cold, desert world with a very thin atmosphere, also called the red planet. Jupiter is the fifth planet from the Sun. Jupiter is by far the largest planet in the solar system. Saturn is the sixth planet from the Sun. It is the second largest planet in our solar system. Uranus is the seventh planet from the Sun. It has the third largest diameter in our solar system. Uranus gets its blue-green color from its gases in the atmosphere. Neptune is the eighth and most distant planet in our solar system. Neptune is dark, cold, and very windy. Neptune is an ice giant. Now, I will hand over the other part to Govind.
Dwarf planets. Pluto, discovered in 1930, orbits the Sun at an average of 39.5 times the Earth's distance. Eris, the largest dwarf planet, is only slightly bigger than Pluto, at 1,445 miles in diameter. Haumea, this dwarf planet has an extremely elongated shape, with its longest dimension being about 1,218 miles long. Makemake, discovered in 2005. Makemake orbits at 45.3 times Earth's distance. Sirius, first spotted by astronomers in 1801, was first called a planet and later an asteroid. In 2006, it was reclassified as a dwarf planet. Sirius is the closest dwarf planet to Earth. Project overview. Select. This tool is used to select one or more circles, delete a node, and move the planets around the Sun. Subselect. This tool is used to select and manipulate circles and adjust the length of lines around the planets. Add line. This tool is used to add line to a node. Add circle. This tool is used to attach circle to a node, which helps in making Sun, orbit and the other planets. Controller. To control the playing, rewind, pause and adjust the speed in project playback. Created comets and stars using add line segment from tools and changed its color to white from segment properties. Changed background color to black, space effect from stage properties. Working. To create the solar system in stacks. Step 1. First, create orbits the Sun and the 8 planets by selecting Add Circle segment from Tools. Step 2. To fill the color in the Sun and the planets, select Subselect segment from Tools. In this way, my first frame got ready. Step 3. To move the planets in the orbit around the Sun, click on Select Segment in Tools. With the help of yellow node, move the planets by adding frames one by one. Step 4. Create comets and stars by using Add Line segment using Tools and change its color to white from Segment Properties. Step 5. To move the comet, first click on the Select segment from Tools. With the help of yellow node, move comet slowly between the orbits and planets by adding frames. Let's get started with the project. So in this solar system project, I made comets, sun, the planets. The planets I made from circle and I drew circles and the spiky lines for the sun. And I fill color in the planets and the orbits. In the last, I made one line as a comet and I filled the color to white. It was great learning experience for us as it was the first animated project on my favorite topic, the solar system. We explored the animated platforms types while working on the project. We learned how to design the solar system in the animated form by creating circles and then moving them in a particular order. To make them look more attractive by adding colors to them was great. To make it closer to reality, we explored about creating comets and stars. So from the solar system animated project, we learned each and every step from creating a node to getting desired solar system. Thank you.
Thank you. Hello friends, my name is Vibhor and I have my partner Adira with me today. Today we are going to learn about solar eclipse. First we need to learn the introduction of solar eclipse. A solar eclipse occurs when a portion of the earth is covered in a shadow caused by the moon which fully or particularly blocks the sunlight. This occurs when the sun, moon and earth are arranged. We need to know if we see different types of eclipse. So we do not know which eclipse that. So let's learn about different types of eclipse. There are 4 types of eclipse. 1. Total eclipse, a lunar eclipse, hybrid eclipse, partial eclipse. First we will look at total eclipse. Total eclipse. Total solar eclipse happens when the sun is completely blocked by the moon. A lunar eclipse. A lunar eclipse and a lunar eclipse is when the moon doesn't cover the entirely of the sun, even if the moon completely centered in front of it. This happens because moon's orbit is an eclipse and the moon is close to the earth. Hybrid eclipse. Hybrid eclipse is a bit simple. An hybrid eclipse is a combination of total eclipse and a lunar eclipse. It's starts as one type and transition to another. Partial eclipse. Partial solar eclipse are when the moon doesn't completely cover the sun. The moon passes off center and only a portion of the sun is observed. Now I'm going to give rest of the part to Adira.
Do's and don'ts while watching solar eclipse. Firstly, do not look directly at the sun. Secondly, do not use homemade filters or ordinary sunglasses, even very dark sunglasses. Thirdly, use special solar filters such as eclipse glasses or handheld solar viewers view the eclipse. Fourthly, read and follow filter instructions and supervise through them. First, in any stage of eclipse, do not look at the sun through a camera, telescope, binoculars, other optical device, and never use solar filters with these devices as concentrated solar rays will damage them and can cause serious eye injury. Second, inspect your solar filter before use. If it's scratched or damaged, discard the filter. Project overview tools used. First, add circle. This tool is used to attach circle to a knot, which helps in making sun, orbits and other planets. Second, controller. The control plane rewind, pause and adjust the speed of the project playback. Third, change the background color to create space effect from stage property. Working. Step 1. First, create the sun and the earth by selecting Add Circle segment from Tools. Step 2. To fill color the sun and the earth, select Subselect segment from Tools. In this way, my first frame got ready. Step 3. To move shade above the sun, click on Select segment in Tools and with the help of yellow knots, move the shade by adding frames one by one. Let's get started with the project. Conclusion. We have learnt about solar eclipse. We have explored about sticks and has learned how animation can be done using the software. Thus, from this project we learnt each and every step. Project overview tools used. First, add circle. This tool is used to attach circle to a knot, which helps in making sun, orbits and other planets. Second, controller. The control plane rewind, pause and adjust the speed of the project playback. Third, change the background color to create space effect from stage property. Working. Step 1. First, create the sun and the earth by selecting Add Circle segment from Tools. Step 2. To fill color the sun and the earth, select Subselect segment from Tools. In this way, my first frame got ready. Step 3. To move shade above the sun, click on Select segment in Tools and with the help of yellow knots, move the shade by adding frames one by one. Let's get started with the project. Conclusion. We have learnt about solar eclipse. We have explored about sticks and has learned how animation can be done using the software. Thus, from this project we learnt each and every step from creating a knot to get a complete solar eclipse. Thank you. Let's get started with the project. Conclusion. We have learned about solar eclipse. We have explored about sticks and has learned how animation can be done using the software. Thus, from this project we learned each and every step from creating a knot to get a complete solar eclipse. Thank you.
Mission Possible. The objective of the project is the launch of a rocket successfully in spite of the presence of debris in space. Here's the stages of rocket forming as satellite and strategy of debris clearance is depicted here. Space junk. Space junk or space debris is any piece of machinery or debris left by humans in space. It can be referred to big objects such as dead satellites that have been failed or left in orbit at the end of their mission. It can also refer to smaller things like bits of debris or paint flecks that have been fallen off a rocket. Galaxies. A galaxy is a huge collection of gas, dust, and billions of stars and their solar system. These are held together by the gravity. The examples are Milky Way, large megalithic cloud, small megalithic cloud, and comet galaxy, etc. Project overview. The tool that was used is Scratch. The number of sprites used is 16 and the number of backgrounds used is 7. In this project, the satellite gets launched and successfully orbits the planet in spite of debris at space. The rocket gets launched through a countdown. The rocket gets separated as it moves into the space through different intervals. The satellite is equipped with sensors and missiles to obstacles such as space junk. The idea of equipping with missiles helps the satellite to reach the orbit by breaking the obstacles on its way. Working. The main blocks used here is glide, start sound and go to. Let's get started. Here's the code of the debris. Here's the code of the rocket. Here's the code of the pair of the missiles.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0, go! Small debris detected. Shoot! Big debris detected. Missile launch required. Way cleared for orbiting Saturn. Wow! Successfully orbited Saturn.
Conclusion. Understood about the space debris and galaxies. I also understood the different stages of rocket launch. I learned the extensions on Scratch such as text-to-speech. I learned the sensing block. I also mastered Scratch. It is evident that everything is possible if required solution or thoughts is implemented. Thank you.
Hey guys, today in this video I'm going to show my presentation, PPT, PowerPoint presentation, project report on galaxies and space junk. It was done by Anish Ram Kumar. My name is Anish Ram Kumar. I am in grade 5. So let's see the next slide. Introduction. Galaxies are made of billions of stars as well as their solar systems. Our galaxy, the Milky Way, also has a supermassive black hole in the middle. Our solar system, or the system of planet that revolves around the sun, is just one of the many systems in a galaxy. A solar system contains one star around which planets orbit, whereas a galaxy can contain from 100 billion to over a trillion stars. Solar system consists of a sun to its center, whereas a galaxy usually has a black hole at its center. While there are about 2,000 active satellites orbiting Earth at the moment, there are also 3,000 dead ones littering space. What's more, there are around 34,000 pieces of space junk, bigger than 10 centimeters in size, and millions of smaller pieces that could nonetheless prove disastrous if they hit something else. Now, let us learn more about galaxies. A galaxy is a huge collection of gas, dust, and billions of stars and their solar systems, all held together by gravity. The gravity is a force that pulls everything to the center. There are many types of galaxies. Here are some types. Example: spiral galaxy, lenticular galaxies, elliptical galaxies, and irregular galaxies. We live in a galaxy called the Milky Way. Now let's come to space junk. Space junk is any sort of machinery left by humans in space. And when that machine is dead, it is considered a space junk because it's no more in use and it will fly somewhere. Example: when satellites, asteroids or meteorites crash, it will break. Or when connection is lost, it will fly somewhere. Thus, it is considered a space junk. Project overview. The project deals with galaxies and space junk. It is totally developed in the Scratch platform. The sprites and backdrop uploaded in the form of a GIF image to make it more realistic. The project is developed in the form of a conversation-based one. Text-to-speech block is focused much to create a set of questions with answers. It is developed in such a way that the astronaut will ask questions to the robot, and it is helping the astronaut by answering the questions in the form of text and sound and repairing the spaceship. Working project is about understanding the space junk in galaxies. Sprites used are Sprite 1, Spaceship. Spaceship is used to explain the harmful impact of space junk. Sprite 2, Astronaut. Astronaut is used to explain about space junk and galaxies. Sprite 3, Robot. Robot is used to ask questions. It starts with a conversation. The astronaut wanted to reach the other galaxy by spaceship. Since his spaceship got damaged by space junk, he asked help to the robot to repair his spaceship. Then the robot repaired the spaceship and cleared his doubts also. Let us get started. Today in this project I am going to show you my Scratch project. The blocks I used were motion, look, sound, events, controls, sensing, operations, then variables, then my blocks. The main was text-to-speech blocks. I got it from add extension block. So I used the sprites I used were a spaceship, an astronaut, then a robot. I got the spaceship and the astronaut from Google. Now you can see what my outcome of the project. Let's start watching my project. 3, 2, 1 and go!
Hello. I am Robotnik. What's your name?
My name is Duke.
Hi, Duke. Why have you come here?
I heard you had some problem, so I came here to help you. Can you please explain your problem?
I came here in a plan of going to another galaxy named the Andromeda Galaxy. It is the closest galaxy to Milky Way I am from. But because of some space junk, my spaceship got destroyed. Do you know what is a space junk?
No, I don't know what is a space junk. Can you explain?
Sure, I will explain. Space junk is any piece of machinery left by humans in space. Then when asteroids or meteorites crash on it, it will break and TH.
And those particles will be considered as space junk.
Oh cool, I did not know it. Thank you for telling it.
Now can you help me in repairing my spaceship?
Sure, I will help you.
Thank you for repairing my spaceship. Bye-bye.
And the astronaut and spaceship have again started with their journey. Thank you for watching my video. Stay home, stay safe. Conclusion. The project paves the way for exploring the facts related to solar system. It paves the way to explore the interesting facts about how space junk exists in galaxy. To sum up the facts in the form of a conversation between an astronaut and a robot, and providing the answers in an exciting and interesting way. Scratch acts as a great platform. You can think, create and do anything with Scratch. Thank you.
Hello everyone, I am Devasena. Today we are going to report a project on Task the Space Chatbot, submitted by me, Devasena and Narayan. The introduction of our project. In the big universe, a small part is Milky Way. In the Milky Way, a small part is solar system. In the solar system, we can find some rocky objects. They are called asteroids and meteoroids. They are also known as minor planets. Asteroids that are on collision course with Earth are called meteoroids. When a meteoroid strikes our atmosphere at high velocity, friction causes this chunk of space matter to incinerate in a streak of light known as a meteor. If the meteoroid does not burn up completely, what's left strikes Earth's surface and it is called a meteoroid. Now let's talk about asteroids. Asteroids are small rocky objects orbiting the Sun. They are found in the asteroid belt of Jupiter and Mars. Asteroids are material left over from the formation of our solar system. One theory suggests that they are the remains of a planet that was destroyed in a massive collision long ago. In fact, if the estimation of total mass of all asteroids was gathered into one single object, the object would be less than 1,500 kilometers or 932 miles across, less than half of the diameter of a moon. Now, let's talk about meteoroids. Meteoroids. A meteoroid is a small rocky or metallic body in outer space. Objects smaller than this are classified as micrometeoroids or space dust. When a meteoroid enters Earth's atmosphere at high speed and burns up, the fireball or shooting stars are called meteors. Some meteoroids contain grain of dust, or it's even called as stardust, that were produced by stars before the formation of a solar system. Studies of these pre-solar grains can increase our understanding of stars' formation and evolution. Now, the project overview. The project concentrates on the other parts of solar systems such as asteroids, meteoroids, meteors, and so on. Out of all this, the main focus is given to asteroid and meteoroid. It is completely developed in Scratch platform. The sprites and backdrop uploaded in the form of a GIF image to make it more realistic. The project is developed in the form of conversation. Sound block is focused much to give the voice over to sprites. It is developed in such a way that the chatbot giving answers for the question asked by the two sprites. Now let's see the working of this project. For the working, the focus is given to the control loops, events, sensing, and sound blocks. It is developed in such a way that both sprites are discussing about other parts of solar system and galaxy and asking the doubts to task the chatbot. It starts from the two characters having a conversation. Then they decided to ask what an asteroid and meteoroid to the chatbot. Then the chatbot answering for the questions asked by the two characters. Now let's get started. I'm going to hand over the project to Narayan.
I am Narayan. I am going to explain and show the Scratch project Task the Space Chatbot. It starts with two characters who are Blake and Jake. After the school ends, they are talking about space. Then they get a doubt what are asteroids and meteoroids. So they ask Task the Space Chatbot and Task answers their question. Now I will play the program.
Hello, Jake. Hi, Blake. Do you think only planets exist in galaxy?
No, we have other things, asteroids and meteoroids and so on.
Oh, that's cool. What is asteroid and a meteoroid?
Come on, let's ask Tars the robot.
Hello, I'm Tars the robot. I was launched to take a picture of an asteroid and a meteoroid. Do you know what is an asteroid? Okay, then I can tell you what is an asteroid. Asteroids are small rocky objects that orbit the Sun. They are found in the asteroid belt of Mars and Jupiter. Do you know what is a meteoroid? Okay, then I can tell you what is a meteoroid. A meteoroid is a small rocky or metallic body in outer space. Objects smaller than this are classified as micrometeoroids or space dust. Thank you. I hope your doubts are clarified.
To conclude, the project paves the way for exploring the other things exist in galaxy. The exploration of other parts of solar system gives a detailed understanding about asteroids, meteoroids, meteors and other things present in the solar system. to sum up the facts in the form of a conversation and providing the answers in an excited and interesting way through a chatbot, Scratch acts as a great platform. Thank you.
Hello everyone, my name is Deena and my teammate is Anvita. Our project name is Comets and Artificial Satellites. A very interesting topic, isn't it? Let's get started. Introduction. So what's the solar system made of? The solar system is made up of a star, planets, moons, comets, asteroids and other space rocks and dust. Comets are space snowballs made from dust and ice that orbit the sun. A satellite is an object, natural or man-made, that orbits something bigger than itself. Our natural satellite is the moon. Sputnik 1 was the first artificial satellite launched by Russia. Artificial satellite. An artificial satellite is an object that people have made and launched into orbit using rockets. Humans have been launching satellites for many uses like communication, weather, military, scientific. Project overview. The project is completely developed in the Scratch platform with a quiz-based approach using sprites and backdrops. There are 12 questions with answer which helps us to understand about comets and artificial satellites. Okay, so how does it work? It starts displaying space quiz with background changes. Then a rocket is made to fly and landed on the moon. An astronaut comes out of the rocket and asks a set of questions and it finally tells the score you have got. Let's get started. An inspirational music starts. First, Earth gets hit by a comet. Then a comet flies. Then an artificial satellite takes pic of the Earth. Then Earth spins. Then a rocket flies and lands on the moon. An astronaut comes out of the rocket and asks, "Do you want a quiz?" If yes, it's asked a set of 12 questions. If no, it says bye. If he or she provided the correct answer, it will congratulate and add a score. If he or she tells the wrong answer, it tells the correct answer. Now let us see the output.
Hello, my name is Akov. What's your name? Dina, do you want a quiz about space? Okay, then let's start. There will be points too.
Our first question is, what is a satellite?
Yes, you are correct.
Our second question is, which is a natural satellite?
Yes, you are correct.
Our third question is, how long does a geostationary satellite take to orbit the Earth?
Yes, you are correct.
Our fourth question is, satellites travel a dash miles per hour. That means, in a given day, satellites can travel the entire circumference of the Earth about dash times.
Amazing, you are correct.
Our fifth question is, which Indian satellites are used for weather forecasting?
But the answer is Kalpana 1, INSAT 3A and INSAT 3D.
Our sixth question is, which is the Indian latest communication satellite?
Fantastic, you are correct.
Our seventh question is, where does a comet come from?
No. But the answer is comets spend most of their lives far away from the sun in the distant reaches of the solar system.
Our eighth question is, how fast is a comet?
Incredible, you are correct.
Our ninth question is, what are the four parts of comet?
Wrong, but the answer is a comet is made up of four visible parts: the nucleus, the coma, the ion tail, and the dust tail.
Our 10th question is, what are comets made of?
Incredible, you are correct.
Our 11th question is, who named comets?
Good job. You are correct.
Our last question is, what is the largest comet?
Good job. You are correct. That's all, your score is 9. Thank you, bye.
Now let's come back to the conclusion. With the project, we explored facts related to the solar system. It gives a good understanding about artificial satellites and comets. Thank you.
Hello everybody, my name is Anrita. I am from class 5B BVM Global School. Today I am gonna talk about my project. My project name is A Visit to Comets. Our universe is too vast and beautiful, which is beyond our imagination. There are so many objects in our universe. Comets are one of them. In ancient times, people tend to believe that if something bad is about to happen, God sends them a signal through these comets. But as time passed, they tried to know the fact about comets. So, they started gathering information about the universe and comets. So, what are these comets? Let's find out. The word comets comes from the Greek word komos, meaning long dead. Comets are frozen leftovers from the formation of the solar system, composed of dust, rock, and ice. Comets are small celestial bodies that orbit the sun. One of the distinguishing features of a comet is that most of them develop a tail, known as a coma. When they come close to the sun, comets usually have two tails, which point in different directions. The dust in the comets is responsible for one tail. This tail, also called the dust tail, tends to be broad and curved. The gases in comets make the other tail called the plasma. Comets are invisible except when they are near the sun. By far, the most famous comet is Comet Halley. Halley is a periodic comet and is visible from Earth every 76 years and has been for centuries. It made its last appearance in 1986. Overall, this project is about comets and facts about comets. There is an astronaut who is explaining about comets and a dog who is curious to know about comets. The whole project is developed in Scratch 3.2. Astronaut and dog are two sprites downloaded from Scratch itself. There are three backgrounds used in this project. First one is downloaded from Scratch. The second one is downloaded from Google. And the third one is drawn from Scratch. working. Different types of blocks like sound, broadcasting, switch, costume, play, sound, wait, speak, etc. are used to make this project. It is developed like conversation between two sprites who are in a space ship visited to space to know about comets. Let's get started. So everybody, this is my working area of my project. I have used some blocks for the game, and those are motion, look, sound, events, control, and etc. So I have made some costumes for each sprite. These are the sprites and background also. Costumes like this one I have used, and in backgrounds also I have some costumes like this one. So this is my block area. Now I'm going to show you the game.
Hello. My name is Lily.
Hi, my name is Tutu. So what are we doing today, Lily?
Today we will learn about comets.
Comets? What are comets? Can I know?
Wait,
Whoa! What are these? They look amazing.
these are comets, other known as shooting stars.
Wow! Can you tell me more about this?
Okay, listen. The word comet comes from the Greek word kometes, meaning long hair. Comets are frozen leftovers from the formation of the solar system composed of dust, rock and ices. Comets are small celestial bodies that orbit the sun. Comets are invisible except when they are near the sun.
Thank you for the lesson, Lily. It was amazing. I love you. So this was my project. So this is my project on comets. While making this project, I have gathered a lot of information about comets and got to know a lot of operations in Scratch. Overall, it is one wonderful experience of my life. Hope you all liked it. Thank you.
My name is S. Sai Samita of Class 6A. Today I will be showing you all the space agencies from around the world. Space agencies. There are many space agencies from around the world, namely NASA, ISRO, CSA, etc. In this PPT, we will see the space agencies and more about them. NASA. NASA stands for the National Aeronautics and Space Administration, is an independent agency of the US federal government responsible for the civilian space program as well as aeronautics and space research. NASA was established in 1958, succeeding the National Advisory Committee for Aeronautics. ISRO, the Indian Space Research Organization, is the National Space Agency of India, headquartered in Bengaluru. It operates under Department of Space, which is directly overseen by the Prime Minister of India, while the chairman of ISRO has as executive of DOS as well. JAXA. The Japan Aerospace Exploration Agency is the Japanese National Aerospace and Space Agency through the merger of three previously independent organizations. JAXA was formed on 1st October 2003. Roscosmos. The Roscosmos State Corporation for Space Activities, commonly known as Roscosmos, is a state corporation for the Russian federal responsibilities for space flights, cosmetics for programs, and aerospace research. China National Space Administration, or CNSA. China National Space Administration is the national space agency of China, responsible for the national space program and for planning the development of space activities. Canadian Space Agency, or CSA. The Canadian Space Agency is the national space agency of Canada, established in 1990 by the Canadian Space Agency Act. The agency is responsible to the Minister of Innovation, Science and Economic Development. The president is Lisa Campbell, who took the position on September 3, 2020.
Good morning, my name is Kishore. I am from class 6. Today I am going to explain you about space stations. Let's see the importance of space station and about 3 space stations: Skylab, Mir and ISS. Let's see the importance of space station. The space station has made it possible for people to have an ongoing presence in space. Human beings have been living in space every day since the first crew arrived. The space station's laboratories allow crew members to do researches that could not be done anywhere else. Now let's see about the Skylab. Skylab was the first United States space station launched by NASA in 14th May 1973 at 5:30 p.m. It was occupied for about 24 weeks between May 1973 and February 1974. It was operated by 3 astronaut crews: Skylab 2, Skylab 3 and Skylab 4. Major operations included an orbital workshop, a solar observatory, Earth observation and hundreds of experiments as of 2021. Skylab was the only space station operated exclusively by the United States. MIR. MIR was launched in 20 February 1986. This space station was operated in low orbit from 1986 to 2001, operated by the Soviet Union and later by Russia. MIR was the first model space station and was assembled in orbit from 1986 to 1996. It had a greater mass than any previous spacecraft. At the time, it was the larger artificial satellite in orbit, succeeded by the International Space Station. After MIR's orbit decay, the station served as a microgravity research laboratory in which crew conducted experiments in human biology, physics, astronomy, meteorology, and spacecraft system with the goal of developing technologies required for permanent occupation of space. Now let's see about ISS. The International Space Station ISS is a model space station, habitable artificial satellite in low Earth orbit. It was launched in 20 November 1996. It is a multinational collaborative project involving 5 participating space agencies: NASA, United States, Roscosmos, Russia, JAXA, Japan, ESA Europe, and CSA Canada. The ownership and use of the space station is established by intergovernmental treaties and agreements. The station served as a microgravity and space environment research laboratory in which scientific is conducted in astrobiology, astronomy, meteorology, physics, and other fields. The ISS is suited for testing the spacecraft system and equipment required for possible future long durations missions to the Moon and Mars.
Astronauts and cosmonauts and space stations TPC. There's lots of work to operate the many science experiments on board. The crew also has to make sure that the station is in top shape. So they clean, check equipments, maintain and repair or replace broken equipments. Crew members also must exercise 2 hours each day to stay fit and keep their bones and muscles strong. Sometimes we need to do all a space walk to work outside a station in our space suit. It's a tough and dangerous job, but the view is stiff.
Good morning. My name is Danyashri from class 6B. I'm going to tell about a space mission. Apollo. Mission to send humans to moon. The Apollo program, also known as Project Apollo, was the third United States human spaceflight program carried out by the National Aeronautics and Space Administration (NASA). It succeeded in preparing and landing the first humans on the moon from 1968 to 1972. It was first conceived during Dwight D. Eisenhower's administration as a 3-person spacecraft to follow the 1-person Project Mercury, which put the first Americans in space. Apollo was later dedicated to President John F. Kennedy's national goal for the 1960s of landing a man on the moon and returning him safely to the earth. In an address to Congress on May 25, 1961. It was the third U.S. human spaceflight program to fly, preceded by the 2-person Project Gemini, conceived in 1961 to extend spaceflight capability in support of Apollo. Kennedy's goal was accomplished on the Apollo 11 mission when astronauts Neil Armstrong and Buzz Aldrin landed their Apollo lunar module LM on July 20, 1969 and walked on the lunar surface while Michael Collins remained in lunar orbit in Command and Service Module CSM, and all 3 landed safely on Earth on July 24th. 5 subsequent Apollo missions also landed astronauts on the moon, the last Apollo 17 in December 1972. In these 6 space flights, 12 people walked on the moon.
Hello everyone, my name is Tejas. I'm from class 6. I'm going to talk about space missions. I'm going to talk about the space mission Mars, marking India's first venture into the interplanetary space. MOM, which is Mars Orbital Mission from ISRO, will explore and observe Mars surface features, morphology, mineralogy, and Martian atmosphere. The enormous distance involved in interplanetary missions present a demanding challenge. Developing and mastering the technologies essential for these missions will open endless possibilities for the space exploration. After leaving Earth, the orbiter will have to endure the interplanetary space for 300 days before Mars capture. Apart from the deep space communications and navigation guidelines control capabilities, the mission will require autonomy at the spacecraft end to handle contingencies. Now let us see the mission launch. MOM, Mars Orbital Mission, made it the 4th space agency to achieve Mars orbit, after Roscosmos, NASA, and the European Space Agency. Made India the first Asian nation to reach Martian orbit and the first nation in the world to do so on its maiden attempt.
Thank you. Now I will hand over this to Danyashri.
Apollo is a space mission by NASA. The Apollo program, also known as Project Apollo, was the third United States human spaceflight program carried out by the National Aeronautics and Space Administration (NASA). Human spaceflight. Human spaceflight is spaceflight with a crew or passengers aboard a spacecraft, the spacecraft being operated directly by the onboard human crew. Spacecraft can be also remotely operated from ground stations on Earth. Apollo set several major human spaceflight milestones. It stands alone in sending crewed missions beyond low Earth orbit. Apollo 8 was the first crewed spacecraft to orbit another celestial body, and Apollo 11 was the first crewed spacecraft to land humans on one. The mission succeeded in preparing and landing the first humans on the moon from 1968 to 1972. The Apollo program returned 842 pounds or 382 kg of lunar rocks and soil to Earth, greatly contributing to the understanding of the moon's composition and geological history. The program laid the foundation for NASA's subsequent human spaceflight capability and funded construction of its Johnson Space Center and Kennedy Space Center.
Hello everyone. My name is Samyak and this is my friend Vasudev. We have made a robotics project on the topic our universe and galaxies. We will discuss about the stars, the universe and the galaxies. A small introduction to the topic. The Big Bang. There was a singularity that exploded, of which the result was that all matter and time began. Soon, the universe which was just created started cooling down, forming stars, galaxies and black holes. Now, the universe is expanding. Our universe. What is the universe and what does the universe consist of? Stephen Hawking once said, God may exist, but science can explain the universe without the need for a creator. Now, the universe has come a pretty long way since the Big Bang. And time, of course, makes things more complex, and our universe is no exception. It started from a singularity, which was 1,000 times smaller than a pinhead, and now is larger than anything we can ever imagine. Now, the universe is not just a pitch black place filled with strange things. It is a rather special and an unknown place. The universe started off with a bang. No, literally. And the universe is currently expanding at an amazingly fast rate. It dates to about 13.8 billion years. It's time to move on to galaxies. So what are galaxies and how do they form? Well, a galaxy is a colossal structure or a cluster of stars and solar systems and much more. And these galaxies have a supermassive black hole at their center. The black holes have a rather huge gravitational force, but it is usually not enough. And this is where dark matter comes to the rescue. The Milky Way is our home, and it is a barred spiral galaxy. Like many other galaxies, our Milky Way also has a supermassive black hole at its center called Sagittarius A. Did you know that even galaxies can have satellites? Dwarf galaxies often revolve around larger ones. There are three types of things in the universe, which is dark energy, dark matter, and matter. So dark energy is an inexplicable force which is responsible for the breakneck expansion of the universe. Dark matter, on the other hand, is invisible because it does not absorb, emit, or reflect light. And matter, which we every day see around us, and which most planets and stars are made up of. This is a graph which shows the distribution of matter in our universe. Our Firo.
Hello everyone, my name is Vasudev and today I will be talking about the codes. So let's start with the background. The code of the background is importing the background first, which is a must, resizing the background, the message received, and changing the background.
Now let's talk about the code for the spaceship. First, we imported the spaceship with a transparent background. Then we added its dialogues and the movement blocks where it glides. And we broadcasted messages which are then received by the background to the different places it goes, like the universe, Andromeda, and its home planet.
Now we will discuss the codes for the asteroids. First, we receive the spaceship's message. Second, we begin the script. And third, we move the sprite to the required position. Thank you.
Thank you.
Good morning everyone, my name is Diya Prabhu. I am studying in 7th standard A section and my partner is Miss Avani Veni. She is studying in 7th standard B section. I am going to explain the presentation. My partner Avani Veni will explain the coding part. Solar system. The solar system is the gravitationally bound system of the sun and the objects that orbit it, either directly or indirectly. There are 8 planets in the solar system. They are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. Stars. A star is an astronomical object consisting of a luminous sphere of plasma held together by its own gravity. The nearest star to the Earth is the Sun. Many other stars are visible to the naked eye at night, but due to their immense distance from Earth, they appear as fixed points of light in the sky. Moon. The moon is the Earth's only natural satellite at about 1/4 the diameter of Earth, comparable to the width of Australia. It is the largest natural satellite in the solar system relative to the size of its planet. The 5th largest satellite in the solar system overall and is larger than any known dwarf planet. Thank you.
Good morning all. Myself Avani Vini from 7B. This project is done by me and my teammate Diya Prabhu from class 7A. Let me start the project for you all.
My first question is, what is solar system?
The nebular hypothesis is the most widely accepted model to explain the evaluation of the solar system. It suggests that the solar system is formed from gases and dust orbiting the sun. The theory was developed by Immanuel Kant.
When and how did the evaluation of solar system? Please explain in detail.
You have asked a really good question. The solar system began about 4.5 billion years ago with a gravitational collapse of a small part forming a giant molecular cloud. Most of the collapsing mass collected in the center, forming the sun, while the rest flattened into protoplanetary disk, out of which the planets, moons, asteroids, and other small solar system bodies formed.
Now we have finished the question answer session. Based on that question answer session, we are going to have a small quiz. We will be given some time to answer the questions of the quiz.
Which is the most widely accepted theory to explain the solar system? Answer: Nebular hypothesis is the most widely accepted theory to explain the solar system. How many years ago solar system formed? Answer: 4.5 billion years ago the solar system formed.
Thank you.
Hi all, my name is Kishore and I'm from BVM Global, Bengaluru, and I have with me my project companion Ishan. He will give you a walkthrough on the PPT. Over to you, Ishan.
Thanks everyone. My name is Ishan Srivastava and I am from class 7B of BVM Global School at Bengaluru. Today I will be talking about the Big Bang Theory. The Big Bang Theory is how astronomers explain the way the universe began. It is the idea that the universe began as a single point known as a singularity. Then it expanded and stretched to grow as large as it is right now and is still expanding. To understand more about the Big Bang and how it happened, we need to know about singularities. So, what is a singularity? Let's take for example a sphere. We squeeze it, but the mass stays the same, but its volume changes. If we keep squeezing it, the ball will become tiny but will be just as massive as it was before. If we squeeze it further and it gets to a critical size, the speed that a moving object must go to escape its gravitational pull will be equal to the speed of light. And since the speed of light is constant, nothing can escape it. So, a singularity is a point where the gravitational field as well as the density of a celestial body becomes infinite. Now coming back to the topic, the origin of the universe. According to the Big Bang, the whole universe was together at one singularity. There was a huge explosion which resulted in the formation of galaxies. These galaxies then divided and formed stars, planets, moons, and etc. At the moment of the Big Bang, the singularities rapidly expanded, creating all the space, time, matter, and energy of our physical universe. Georges-Henri Joseph Edouard Lemaitre was a Belgian Catholic priest, mathematician, astronomer, and professor of physics at the Catholic University of Louvain. He was the first to propose about the Big Bang theory in 1927. In reality, very little is known about the origin and the current state of the universe. We have made a first attempt at explaining the answers that science has revealed about our universe. Our understanding of the Big Bang, the first atoms, and the age of the universe is obviously incomplete. As time wears on, more discoveries are made, leading to infinite questions that require yet more answers. Now, my project companion Kishore will give you a visual display on how the Big Bang might have happened and how it had created life.
Thank you, Ishan, that was great. You must have all heard about the Big Bang Theory, but now I will show it to you visually. Now, the singularity
singularity is expanding. Now it explodes to form the time, matter, planets, space, and life. Atoms combine together to form a molecule. 3 or more molecules combine together to form life. You must have all heard this in a theory, but now I will show it you visually. All the molecules are combining to form life. The sun moving from the east direction to the west direction indicates that time is formed. Now, let's see a natural conversation between a robot and a human. I, Kishore, have played the role of a robot who's asking the questions, and my project companion, Ishan, has played the role of the human who's answering to the questions. Now, let's have a look at the project. Now, ask you to understand it by conducting a small quiz. What created life on Earth?
All the photons, protons, neutrons, atoms and molecules created life on Earth.
What was the temperature of the singularity before expansion?
The temperature was about 100 million trillion degrees before expansion.
What is a singularity?
A singularity is about the size of a dot, but it has infinite density and gravity, so pretty much nothing can escape it.
What was the Big Bang?
The Big Bang was an explosion of particles which formed space, time, matter and energy. These then formed galaxies, planets, moons and stars.
What could be an alternative name for the Big Bang?
An alternative name could be the explosion that created life.
Thank you. I hope you enjoyed this project.
Impacts of gravity. This presentation explains about the impacts of gravity and how we relate it to our digital project. You can have a digital experience on this project created using Fire Code. A project is solely based on gravity and its effects. Play the game and have fun. What even is gravity? Gravity is a vast topic, but definitely very interesting. As you all know, without gravity, we all will be floating right now. Gravity is the force by which a planet or other body draws objects towards its center. The force of gravity keeps all of the planets in orbit around the sun. In other words, gravity helps pull all objects to the ground. This is the source code of the gravity field. This is a digital project. It basically has a rocket which is linked into wires. Gravity game, based on gravity in space. You can play this game by clicking on the link. This is a simple game in which there are a few obstacles through which the rocket has to survive. You just need to successfully complete the task and you can play it again as a stress buster. Thanks for watching.
Hello everyone, My name is Yutrin and I am from class 9 and this is my robotics project. This is a website made from HTML, CSS and the backend is done with Django. So at first we can go to the stages of the star. So what is a star? Stars are hot bodies of glowing gas that start their life in nebula. They vary in size, mass and temperature, diameters ranging from 450x smaller to over 1000x larger than that of the sun. Masses range from a 20th to over 50 solar masses, and surface temperature can range from 3000 degrees Celsius to over 50,000 degrees Celsius. Stages of a large star. Stage 1. Massive stars evolve into a similar way to a small star until it reaches its main sequence stage. The star shines steadily until hydrogen has fused to form helium. The stage 2. The massive star becomes a red supergiant and starts off with a helium core surrounded by a shell of cooling, expanded gas. The massive star is much bigger in its expanding stage. Stage 3. In the next million years, a series of nuclear reactions occur, forming different elements in shells around the iron core. Stage 4. The core collapses in less than a second, causing an explosion called supernova, in which shock waves blow off the outer layer of the star. Stage 5. Sometimes the core survives the explosion. If the surviving core is between 1.5 to 3 solar masses, it contracts to become a tiny, very dense neutron star. If the core is much greater than 3 solar masses, the core contracts to become a black hole. You can find more about this in our Chandrasekhar Limit project. The types of stars. There are many different types of stars in the universe, from protostars to red supergiants. They can be categorized according to their mass and temperature. There are three main types of stars: giant stars, white dwarfs, and supernovas. Giant stars have low mass stars near the end of their lives. They have a spectral type of G, K, or M. Their temperature ranges between 3000 to 100,000 K. Their radius according to the sun is 10 to 50. Their mass according to the sun is 1 to 5. White dwarfs are a dying remnant of an imploded star. Their spectral type is D. Their temperature is under 80,000 K. Their radius is under 0.01 and then their mass according to the sun is under 1.4. Supergiant star. High mass. These are high mass stars near the end of their lives. Spectral type is O, P, A, F, G, K, or M. Temperatures can be ranging from 4000 to 40,000 K. Radius is, if from the perspective of the sun, is 30 to 500. The mass from the perspective of the sun is 10 to 70. Another type of star called the spectral types of stars. These stars are classified by their spectra, the elements they absorb, along with their brightness, the apparent magnitude. The spectral class of a star can tell astronomers a lot about it. The seven main spectral types of stars. There's the spectral type of O, B, A, F, G, K, and M. Here are some of the stats related. Thank you for watching, and now we have a short presentation about the Chandrasekhar limit.
Explaining my robotics project on Chandrasekhar Limit. I have used Snap for the project. Snap is a free block-based educational programming language which is inspired by Scratch. We can create animations, games, and many more. It is a web application which works without installing. We can make sprites move, we can change their costumes, and we can make them deliver dialogues. We can also add some sounds, make them draw, and there are many more features which we could add. We can add as many sprites as we want. This is where we script our sprites. We can paint our new costumes, or we can import them from the costume library. Here we have stage. This is where we script our programs for the stage. We can paint our background, or we can choose them from the background library. Now I will be explaining how I made my Chandrasekhar Limit project. I have two sprites here which will be playing an important role, named as boy and girl, where each of them have different dialogues that they will be delivering. This is a script of the first sprite. This sprite has two costumes. And this is the script for the second sprite. This sprite has two costumes as well. Stage. This is where I have scripted the programs for the backgrounds.
which will change when each subtopic is spoken. These are the different backgrounds that I have.
Hi, I'm Varshin.
And I'm Kavnya, and today we will be exploring future prospects in space exploration, AI in space science, and Mars colonization. But first, let's get started with AI in space science. Life as an astronaut aboard the International Space Station can be hard work. There are far too many jobs to perform, not enough gravity, dwindling provisions, and the threat of being stranded out in space. Artificial intelligence takes some of the load off astronauts' back and helps them in various tasks. The Simon robot is currently being used to make the life of astronauts less of a chore and maybe even entertaining. Simon was sent to the International Space Station using the Falcon 9 rocket. This flying robot uses voice commands and touch screens to communicate with astronauts.
We also have another robot named Astrobi, which is a cube-shaped robot that helps astronauts with routine tasks and uses AI and machine learning to reduce the time astronauts spend on tasks such as identifying faults in machinery in the space station. These robots are equipped with Bosch's Sound C technology. It can continuously record operating sounds from the equipment on board the space station and send them back to Earth for evaluation by scientists. More importantly, Sound C uses AI-based sound analysis to evaluate the performance of critical machines by detecting subtle and irregularities in their noise patterns. This can be a crucial aid for astronauts and help them in troubleshoot problems before they even arrive. Now that we know about how AI would work in space, let us look at Mars colonization and robots related to that.
Mars colonization is a very complex process which involves a lot of minute details which may look like they are not significant, but they play a major role in why we chose Mars. Some might say, why not the Moon, as it is closer to the Earth than Mars? Although distance is a major factor, we also need to look at other factors like the atmosphere. Mars's atmosphere is composed of CO2 with some nitrogen and argon, which means that we can grow plants on Mars just by compressing the atmosphere. Gravity on Mars is about 38% of that of Earth. Furthermore, a day in Mars has almost the same duration of a day in Earth. As of now, there are many companies competing in the race to the Mars. One of the leading companies is SpaceX. SpaceX has designed a rocket known as the Starship, which we will use to get to Mars. The rocket is 120 meters high and has a diameter of 9 meters. The Starship rocket consists of 3 parts: the Starship, Super Heavy, and the payload.
The Starship is a fully reusable spacecraft and the second stage of the Starship system. It offers a payload section that is capable of carrying passengers and cargo to Earth's orbit and planets. The Super Heavy is the first stage or booster of the next generation launch system and has a gross liftoff mass of over 3 million kilograms and uses subcooled liquid methane and liquid oxygen propellants. The booster will return to land at the launch site on its 6 legs. The Starship payload fairing is 9 meters in diameter and 18 meters high, resulting in the largest usable payload volume of any current or in development launcher. This payload volume can be configured for both crew and cargo. Even though the rockets that we will use to get to Mars is ready, we still need to make arrangements for our stay on Mars. On Mars, we will have to stay in domes which have a petal-shaped structure and constant oxygen supply. The petal shape of the dome makes it easier and faster to construct, and it also makes it easier to transport. Inside the dome, we will need to emulate the atmosphere of the Earth to make our day-to-day lives easier. Now that we know about colonizing Mars, let us look at the future prospects of AI in space science.
AI will play an important role in space exploration. It has helped us discover numerous exoplanets, stars, galaxies, and more recently, 2 new planets in our very own solar system. Artificial intelligence has also established new theories such as Mars once used to have water on its surface. NASA used machine learning to discover Kepler-90I, an exoplanet that orbits a distant sun star only about 2540 light years from Earth. In order to put AI to good use, scientists have to train the model with the help of neural networks to identify recorded signals. In many ways, AI is a great way for humans to overcome the various challenges involved in space travel. The fact of the matter, humans are simply not biologically capable of space travel. To put things in perspective, 70% of all astronauts that go into space get ill because of zero gravity. This is why an AI robot can prove to be useful by identifying patterns in their behavior and giving them medical help as and when they need it.
In the case of deep space missions, AI can play a pivotal role when reporting systems are unable to respond. AI can apply deep learning to facial recognition and speech recognition to establish a conversation with scientists. AI can perform dangerous and redundant tasks that are not suited to astronauts. The use of Simon aboard the ISS and Bosch's Soundsea are 2 great examples of space exploration friendship between machine and human. Soundsea uses its array of microphones and sensors to capture equipment sounds and then uses Bosch's highly advanced AI to identify potential repairs. On Earth, Soundsea could be explored for potential applications in autonomous vehicles and emerging building technologies. We can even imagine the Soundsea technology being used to improve a self-driving vehicle's responsiveness to rescue or law enforcement vehicles by automatically identifying and reacting to sirens and clearing out of their path. Another application for AI in outer space is self-driving spacecrafts, just like self-driving cars here on Earth. Spacecraft operators will have to train machine learning algorithms to steer clear of objects in outer space instead of slamming right into them. There are a lot of use cases where AI can be implemented to gather data, troubleshoot problems, and steer astronauts or critical space equipment clear of danger. In order to truly empower spacecraft operators in outer space, we have to first gain trust in AI through validation activities and traditional verification. Word of caution though, It is of importance to keep human operators in the loop at all times. We are still a long way off before developing fully autonomous systems and making them accessible for scientists.
It won't be long enough before we can deliver AI applications to dramatically expand the capabilities of space systems. For now, AI will continue to comb through the large amount of information.
Welcome to Space Tech. Today we will be seeing some information based on the topics, future prospects in space exploration, AI in space science and Mars colonization. Please press the enter button to continue.
As we saw when we clicked the enter button, it went to the next screen. Here we have this big button called the introduction. Let's see what happens when we press on the introduction button. Oh, it goes to another screen. Here we can see three bubbles: the future prospects in space exploration bubble, AI in space science bubble, and Mars colonization bubble. So let's see what happens when we click the future prospects in space exploration bubble. It moves to the next screen. Here you have two buttons, the play button and the next button, and some information below that. First, let's see what happens when we click the play button.
In the half century since people visited the moon, NASA has continued to push the boundaries of knowledge to deliver on the promise of American ingenuity and leadership in space. And NASA will continue that work by moving forward to the moon with astronauts landing on the lunar South Pole by 2024. NASA's backbone for deep space exploration is the biggest rocket ever built, the Space Launch System (SLS), the Orion spacecraft and the Gateway Lunar Command Module. Nearly a half century ago, Apollo 11 astronaut Neil Armstrong walked on the moon. NASA is now preparing for an ambitious new era of sustainable human spaceflight and discovery.
Wow, the efforts taken by NASA on future prospects in space exploration was very informative. Now, let's see what happens when we click on the next button. So, as you saw, it goes to another screen. Here you can see many pictures and information based on these pictures. What are these pictures? These are some of the projects by NASA on future prospects in space exploration in detail. So let's click on the AI in Space Science button. When we click on the AI in Space Science button, a similar format to the Future Prospects in Space Exploration button is even here. So we can see the play button, the next button, and some information beside it. Now let's click on the play button to hear the information or the facts about AI in space science and how AI has helped in space science.
AI has helped in the discovery of various things in the space through which we get a detailed overview about our universe. The first image of black hole. A 29-year-old computer scientist named Katie Bouman developed an algorithm that created the first ever image of a black hole. The NASA scientist created a network of telescopes known as the Event Horizon Telescope or EHT, which lies at the center of the M87 galaxy 55 million light-years from Earth. The image showed a bright ring with a dark center, which is the black hole's shadow. Later, they set out to capture an image of a black hole by improving upon a technique that allows for the imaging of faraway objects, known as Very Long Baseline Interferometry, or VLBI, which also says that the black hole is 6.5 billion times the mass of the Sun.
Now, since we have heard the information about AI in space science and how AI has helped in space science, let's see the function of the next button. So when we click the next button, it goes to another screen which has pictures and information about these pictures below it. Now, screen too high. The back button and the next button. Now, since we know the function of the back button, that is to go back to the previous screen, let's click on the next button. Okay, now when we click the next button, we saw that it goes back to the subdivision page or the page where we saw the 3 bubbles. Now only one more bubble is left, which is the Mars colonization. Let's click on Mars colonization bubble 2 to see what happens. Now, when we click on Mars colonization, it goes to another different screen which has the play button, the next button and some information. So, let's click on the play button to hear out the information about Mars colonization.
Within the next decade, NASA will finally have a spacecraft capable of making the journey to Mars. The massive new 2,500-ton SLS, combined with the Orion capsule, will enable astronauts to explore beyond the safety of low Earth orbit for the first time since the end of the Apollo moon program in 1972. Landing safely on Mars is also a challenge. NASA used an innovative sky crane to lower its 1-ton Curiosity rover onto the surface in 2012. The Orion capsule weighs almost 10 tons, and that is before you factor in any service module or landing rockets. The agency is currently developing giant inflatable heat shields designed to slow spacecraft as they approach Mars, making landing larger craft feasible.
Wow, wasn't that informative about Mars colonization? Who here is excited to go to Mars? Okay, now let's see the function of the next button. So as we saw, the function of the next button is that it takes us back to the subdivision page. Now we clearly understand that it is the end of the app. So I hope all of you like the app and the application as well as the presentation. So stay home, stay safe and stay healthy. Thank you.